Okay, 7th graders, I am recording this lesson in front of you, which means you guys are in the room. You already know that you need a pencil, something to write with, your book, and a lined sheet of paper. Don't really care what you use as a line or as a writing implement, but please have one. Okay, first off, we have vocabulary. First word, sequence. Sequence is just an ordered list of numbers. I am trying to write larger today so that it is easier for you guys to read. Um, then the word term is just a number in a sequence. So if we have a sequence that goes like, 2, 4, 8, 16, 32, each number in it is a term. The whole thing together is a sequence. And then our last term is arithmetic sequence. An arithmetic sequence, we make it by is a sequence made by adding the same number to the previous term. So if we have a sequence that is, let's say we have a sequence that is a plus 3 sequence. So we have a plus 3 sequence. Every time we're going to add 3 to it. Let's say we start at 7. So we have 7. 7 plus 3 gets our next term. That's 10. Plus 3 is 13. Plus 3 is 16. Plus 3 is 19. Plus 3 is 22. Plus 3 is 25. So each time we added 3 to get the next term. So that makes it an arithmetic sequence. Okay, moving on to the actual lesson itself. Complete the graph organizer below. Arithmetic sequences. Continue each sequence. So we have 1, 3, 5, 7. We are adding 2 to each sequence, and what we're going to have after this is 9. 1, 1.5, 2. We are adding a half to each in each case. Now we are just adding 2.5, 3, 3.5. Describe each sequence. Add. So for this one, we are adding 2 to the previous term. And then for this one, we are adding 0.5. Real world link, horseback riding. The number of students who went on each horseback riding trip is shown. Do the numbers represent the terms of an arithmetic sequence? Explain. So number of trip 1, number of students 15, trip 2 16. So they are adding plus 1 there. But between 16 and 18, that's a plus 2. Between 18 and 21, that is a plus 3. Between 21 and 25, that is a plus 4. So this sequence is not an arithmetic sequence because they're adding 1, 2, 3, 4. They don't add the Describe and extend sequences. Number 1. Describe the relationship between the terms in the arithmetic sequence 8, 13, 18, 23. Then write the next three terms in the sequence. So, between 8 and 13, we've got, they're adding 5, so it's plus 5, plus 5, plus 5. So then we add 5 to 23, and 5 plus 23 is 28. And then 28 plus 5 is 33, and 33 plus 5 is 38. So the next three terms are 28, 33, and 38. Describe the relationship between the terms in the arithmetic sequence 0.4, 0.6, 0.8, 1. Then write the next three terms. So we're adding 0.2 between 0.4 and 0.6. So next three things are 1 plus 0.2, so it's going to be 1.2. And 1.2 plus, down here. 1.2 plus 0.2 is 1.4. 1.4 plus 0.2 is 1.6. So the next three terms are 1.2, 1.4, and 1.6. Let's see if we can do some problems. Describe the relationship between the terms in each arithmetic sequence. Then write the next three terms in the sequence. So we go from 0 to 13. So we're adding plus 13. 13 to 26 is plus 13. 26 to 39 plus 13. If you need to, you can do it in your calculator, but 9 plus 3 is 12. Bring up the 1, 3, 4, 5. 52 plus 13 is 5. 65 plus 13 is 8. 78. 52, 65, 78. Next one, B. 4 to 7 is plus 3. 7 to 3, or 7 to 10 is plus 3. 10 is plus 3 to 13. 16, 19, 21. 1.3, 1.6, 1.9. We're adding 0.3 each time. So we have 2.1, 2.4, and 2.7. And D, we have plus 0.5, plus 0.5, plus 0.5. So next ones are going to be 4.5, 5, 5.5. Next, write an algebraic expression. In a sequence, each term has a specific position within the sequence. Consider the sequence 2, 4, 6, 8. First position is 2, second position is 4, third position is 6, fourth position is 8. Notice that as the position number increases by 1, the value of the term increases by 2. So position 1, position 2, position 3, position 4, operation, and then value of the term. You can write an algebraic expression to represent the relationship between any term in a sequence and its position in the sequence. In this case, if n represents the position in the sequence, then the value of the term is 2n. So the value equals 2 times n. So the value of the term equals 2 times the position. For example, the greeting card that Meredith makes are are sold in boxes at a gift store. The first week, the store sold 5 boxes. Each week, the store sells 5 more boxes. The pattern continues. What algebraic expression can be used to find the total number of boxes sold at the end of the 100th week? What is the total? So we are doing 1 times 5, 2 times 5, 3 times 5. So we have position times 5 equals, and they are selling boxes. This is boxes sold. So, and this P is actually a week. So this is week times 5. So P equals week. And week, we'll just do with a W. And then BS equals boxes sold. These are the symbols we're using. So we have W equals, or 5 times W equals BS. So for 100th week, we put in 100 here. So we have 5 times 100 equals boxes sold. 5 times 100 is 500 equals boxes sold. So at the end of 100 week, 500 boxes are sold. Next up, if the pattern continues, what algebraic expression can be used to find the number of circles in any figure? How many circles will be in the 50th figure? Okay, so we have figure 1, we have 3, figure 2, we have 6, figure 3, we have 9. So the position times 3 equals number of circles. Oh wait, circles is with a C. So P equals, oh, and we'll use figure. And we'll use an F for figure. And C equals number of circles. Now what is our relationship? Well, we have 3 times P equals the number of circles. So we'll substitute that P for an F. So we have figure times 3 equals number of circles. If we put in 50, we have 50 times 3 equals the number of circles. 50 times 3 is 150. So we have 150 circles. Guided practice. Describe the relationship between the terms in each arithmetic sequence. Then write the next 3 terms in each sequence. So 9, 18, 27, we're adding 9 each time. So we have 36, 45, and 54. 4, 9, 14, 19. Let's see, we are doing 5, so we are adding 5. 5 plus 19 is 24, plus 5 is 29, plus 5 is 34. We are adding 0.1, so we have 1.4, 1.5, and 1.6. Hannah has a doll collection. The table shows the total number of dolls in her collection for 3 years. Suppose the pattern continues. Write an algebraic expression to find the number of dolls in her collection after n years. How many dolls will have Hannah collected in 25 years? So we have year times, and we are doing 6 equals number of dolls. And y equals year, and number of dolls equals number of dolls. After 25 years, We have 25 times 6 equals number of dolls. 25 times 6 is 150. Number of dolls. 150 equals the number of dolls. Building on the essential question, explain why the following sequence is considered an arithmetic sequence. 5, 9, 13, 17, 21. So what are we adding? We're adding 4, 4, 4, 4. We add 4 each time, therefore it's an arithmetic sequence. And I want you guys to do the odds. Or no, wait, last time I made you do the odds. This time I'll make you guys do the evens. 2, 4, 6, 8. Ooh, you guys got lucky at not having to do 9, 10, and 12. Okay, good luck, have fun, and go as fast as you can.